Hello everyone. I said I got some new toys, including a document camera, and I know many of you were watching KVL KCL, so I thought I would make a video to see if working through this problem and seeing it work through slowly and at your own pace would be helpful. Like I said, this is foundational. So this is problem 1 of the group work from today's lecture, and we will do it together. So as you see, the problem asks to use KCL and KVL to find the currents I1, I2, and I3. And what we've been given here is we've been given a direction for I1, a direction for I2, and a direction for I3. We have 3 resistors, each of 1 kilo ohm. We have a 5-volt source, and they've already given us some loops. Okay. So first thing we can do always is we can write down our good old friend Ohm's law, and remember the way we define it in the class. If we have resistor R and we have some voltage drop V, the current always is defined as flowing from positive to negative. Okay. Now this becomes very useful because we want to keep our signs straight. So the next thing we can do is then we can go through and we can label each of these 3 circuits using this. So since it goes from this way to this way, I could say positive to minus, and then positive to minus, and then positive to minus. Okay? And if we wanted to, then we could label that. So this is I1, so let's call this R1, and this is I2, so R2 and R3. And we can label each of these voltages as V3, V2, and V1. Okay? Now using Ohm's law, we can say, okay, we know that V1 is equal to I1 times R1. V2 is equal to I2 times R2. And V3 is equal to I3 times R3. So that's just a convenient way to do it. Now the next thing, now that we've labeled everything, and we can then also go through and we can label our loops, and we see our node here. The first one I like to do always is then KCL, right? And that tells us that at a node, the sum of all currents is equal to 0. And current going into a node we say is positive, and current leaving a node we say is negative. Okay? So in that case, we see at this node, right, that we have I1 entering the node, plus I2 is entering the node, plus I3 is entering the node, and that all has to be equal to 0. Okay, so there's our KCL equation. Next, we can use our KVL equations. First, we can do for loop A. Okay. Now, again, we go, what do we do there, right? And this says the sum of all voltages around a loop, is equal to 0. And we then go clockwise. And if we hit a plus first, it's positive. We hit a negative, it's negative, right? And I always start in this bottom corner, and I go around, and I would do the same here. So let's do that, right? So if we go around, the first thing we hit is we hit negative 5 volts. So I can go negative 5 volts. Then I go up here, and I hit positive, and this is V1. So plus V1. Now the current comes around this loop, right? Going around the loop here. We now hit negative V2, right? Hit the negative sign first. And then we come back to where we started, so that's equal to 0. So that's for A. Okay. We can now do the same thing for loop B. Again, I like to start in this corner. I'm just a creature of habit. I hit, boom, positive first, so I'll say V2. Come around, I'll hit the negative first, so minus V3, and keep looping around, come back, so that's going to be equal to 0. Okay, so now what do we have? We have 1, 2, 3, 4, 5, 6 unknowns, right? We have 1, 2, 3, 4, 5, 6 equations, right? So in algebra, if we have the same number of equations as unknowns, we can solve. Now that's a lot, so what would we like to do? the first thing I would like to do is let's simplify. And so we created these voltages, but we have the relation. So what we can do in both cases is let's just substitute in using Ohm's law. So I can say that minus 5 volts plus V1, which is I1R1 minus V2, which is I2R2, is equal to 0. And here, I can further say, again, so V2, so that would be I2R2 minus V3, I3R3 is equal to 0. Okay, so now if I look, I have 1, 2, 3. So now we just have currents, right? So, and I have these here where we also know that R1 is equal to R2 is equal to R3, which is equal to 1,000 ohms from our equation, right? So just to keep that clear. So if we look at this equation, we have I1, so first unknown, R1 we know, I2 second unknown, R2 we know, I2, okay, we already got it, R2 again, we know it, I3 third unknown, okay, and if we look up here, we have just I1, I2, and I3. So now we have 1, 2, 3 equations and 3 unknowns. Okay, so we've now brought it down by half, feeling pretty good. Now, where do we go from here, right? Like what? So what I like to do first is I look at usually my KVL equations, and I try to find the one that's the simplest. Sometimes maybe it's just equal to a constant, and that's easy, or maybe it's a short one. So this one's kind of the shortest, only has 2 things going on, and so we can relate them. So I can now just rewrite this. So we can just rewrite B here. Again, it says I2R2 is equal to I3R3, right? So all I did was I just moved this over, and now I have this relationship, okay? And since we know that up here that R2 and R3 are equal, right? I could say that I2R2 is equal to I3R2, or I could put the numbers in 1,000, and I get this relationship. And because of that, these R2s actually cancel. So I get this relationship that I2 is equal to I3. Okay. Hopefully you're following along so far. Okay, so now we've used up our relation for equation B. So now what do we want to do? So now if we look, we have still this equation from A that has 2 variables here, and we have this one here, right? And this was I1 and 2. This one has I1, 2, and 3, and this has 2 and 3. Well, what I'd like to do is I'd like to remove one of my things to simplify, right? One variable. So here I have 2 and 3. This has 1, 2, and 3, and this has 1 and 2 only. So there's less of 3 than any. So what I'm going to do is take this and substitute it up here. So I can go now and say with KCL that I1 plus I2, instead of then I2, I can substitute, just write I2 again, and that's going to be equal to 0. Right? So you understand there? And now we can rewrite that I1 plus 2I2 is equal to 0. And then we can just move this over the other side, so we get that I1 is equal to minus 2I2. You get a second relation. Okay. So now through this, then we've used our KCL equation up. Okay. So the only one we haven't touched then is this equation here, A, where we have it in this form. And we have this 5 here, so we can move the 5 over. Right, so if I go down here, let me just rewrite it, moving it over. So if I say then that I1R1 minus I2R2 before, right, and I move the 5 is equal to 5 volts, right? Because I move the negative 5, so plus 5. This cancels, and then plus 5 over here, okay? So now I have this relation, right? There's still 2 variables. What I'd like to do then is remove one of them so we can solve. Luckily now I have this relation between I1 and I2, so I can substitute in. Now I don't like making fractions because I always mess them up, so what I'm going to do is, because this is just equal to 1, I'm going to substitute in this right here. So I can rewrite this as negative 2I2 times R1 minus I2 times R2 is equal to 5 volts. Okay. Hopefully that's making sense. So now what we can do is we can go ahead and we can factor that around. So we can pull out the I2 there. So if you go I2 is equal to minus 2 R1 minus R2 is equal to 5 volts. Okay. And then we say that I2 is equal to 5 volts over minus 2 R1 minus R2. Okay. And we can now substitute in where these are 1,000. So we basically what we get. So we get that 5 volts is over minus 2,000 minus 1,000. So that I2 is equal to 5 volts over minus 3,000 ohms. So which says that which is equal to 5 over or minus, right? 3 amps. Okay. So we have this relation here for I2. So now we can write it out. I'll just try to keep it on one piece of paper here. So we know that I2 is now equal to minus 5 over 3,000 amps. Now what do we know? Here we know that I2 is equal to I3. So we can say, okay, based on that, we know that this is equal to negative 5 over 3,000 amps. And then we know that I1 is equal to negative 2 times I2. So we can say that I1 is equal to negative 2 times negative 5 over 3,000 amps. Right, so those cancel. So it's that I1 is equal to 10 over 3,000 amps. So it's equal to 10 over 3,000 amps. And the question asked us to solve for the 3 currents. So now we've labeled it. I would then, in my format, put that in that section, and I've now solved. So I hope this is helpful and just walks you through this. I encourage you to work it yourself as well as do problem 3, and hope you have a great weekend.